In this video, we're going to cover what ionic bonding is, how ions are formed, and what the process of ionic bonding is. Ionic compounds are formed when a metal and non-metal react together. For example, sodium chloride is an ionic compound, and this is commonly known as table salt, so what you put on your chips. If we zoomed in on a molecule of table salt, we would see something like this. We'd have lots of different ions held in a big lattice arrangement. Ionic bonding is the electrostatic force of attraction between oppositely charged ions. So it's the electrostatic force of attraction between the sodium ions and the chloride ions. Ionic compounds have a giant lattice structure, and this is what that kind of structure looks like. So it's a regular arrangement of rows and rows of ions on top of each other, and they have this 3D structure you can see here. If we looked at just one face of that ionic compound we've looked at a moment ago, you would see a repeating pattern of sodium ions and chloride ions. We can simplify that entire structure into a dot and cross diagram. We're going to spend the rest of the video learning how we can draw these diagrams from scratch, showing both of the ions involved. This representation is of the 3D lattice structure we saw a moment ago. It does not mean that there is just one sodium bonded to one chlorine. It's actually the big 3D lattice structure represented in a diagram like this. We're now going to look at how ions are formed. To do this, we need to recap the structure of an atom. An atom has protons and neutrons inside its nucleus. It has then shells around the nucleus where the electrons go. And atoms always have the same number of electrons as protons. So in this example, our atom has 3 protons, so it will also have 3 electrons. These are our 3 subatomic particles: protons, neutrons, and electrons. You need to know the mass and charge of each of these. A proton has a mass of 1 and a charge of 1. A neutron has a mass of 1 and a charge of 0. And an electron has a mass of very small and a charge of -1. Electrons go in shells around the nucleus. You can have a maximum of 2 electrons in the first shell, 8 in the second shell, and 8 in the third shell. Atoms will always try to have a full shell of electrons wherever possible, because this makes them more stable. An ion is an atom or a molecule which has a charge. So for example, if I added an extra electron to my atom, I now have 3 protons in the nucleus still, but now I have 4 electrons instead. This means I've got 3 positive charges in the nucleus and 4 negative charges outside. This means that overall, I will now have an ion with a charge of -1 because I've got 4 negatives, 3 positives, which balances out as 1 negative overall, or a -1 charge. We'll now just reset the atom to how it was before, so 3 protons, 3 positives, and 3 electrons, 3 negatives. And we'll remove one of those electrons. So we've now got 2 electrons in total and 3 protons. So I now have 3 positive charges in the nucleus and 2 negative charges in the shells. This means that overall I will now have an ion with a charge of +1, because 3 positives, 2 negatives balances out as an overall charge of +1. This is the only way to form an ion. We can form an ion by either gaining electrons and having a negative charge, or losing electrons and having a positive charge. We can use the periodic table to figure out how many electrons each element has in its outer shell and therefore what ion it would form. A reminder that the group numbers along the top of the periodic table tell you how many electrons something has in its outer shell. So for example, oxygen is in group 6, so oxygen would have 6 electrons in its outer shell. We'll start off by looking at lithium. Lithium is in group 1, so it will have 1 electron in its outer shell. When forming an ion, we always have 2 options of what we can do with the electrons. Lithium could lose its 1 outer electron, or it could gain 7 electrons to go for a full shell of 8. So we can either lose electrons to go down to 0 in the shell, or gain electrons to go up to having 8 in the shell. An atom will always do the smallest number of changes necessary to form an ion. So in this case, it's easy for lithium to lose 1 rather than gaining 7. So if you imagine this is our lithium ion with 1 electron in its outer shell. We know it's going to lose 1 electron, so we've drawn an after picture showing the lithium without the electron. We know that if we lose electrons, we're going to become positive. We've lost 1 electron, so we're going to have 1 positive charge. So we could write this as Li+. This time, we'll look at chlorine. Chlorine is in group 7 of the periodic table, so it will have 7 outer electrons. As before, we've always got 2 options when we either gain or lose electrons. Chlorine could either lose 7 outer electrons, or it could gain 1 electron to go up to a full shell of 8. We'll always do whatever the smallest number is, so in this case we're going to gain 1 because that's easier than losing 7. We've drawn our chlorine atom here with its 7 outer electrons. And it has now gained 1 electron. It now has 1 more electron than it started off with, so it's going to have a negative charge. So we could write this as Cl-. We'll now look at sulfur. Sulfur is in group 6 of the periodic table, so it will have 6 electrons in its outer shell. This means we've got an option of either losing all 6 or gaining 2. We'll always do the option which requires the least change, so in this case we're going to gain 2 because that's easier than losing 6. So we can draw a before picture of our sulfur with its 6 outer electrons. And we can then draw an after picture showing that sulfur has gained 2 electrons. If we've gained 2, we've got 2 more negative charges than we started off with, so sulfur will have a 2- charge. Or we can write that as S2-. Aluminium is in group 3, so it will have 3 outer electrons. This means we can either lose 3 or gain 5. We're going to lose 3 electrons, as that is easier than gaining 5. So we can draw aluminium before, showing the 3 electrons in its outer shell. and then the after picture where it has lost 3 electrons. If aluminium has lost 3 negative charges, it's going to have a positive 3 charge when it forms an ion. We're now going to look at 4 examples of the process of ionic bonding. The first question we're going to look at is to draw and explain the bonding in sodium chloride. We're going to follow the same general process for each of these 4 examples. The first thing we need to do is draw a before picture showing the outer electrons of each of the 2 atoms involved, in this case sodium and chlorine. Sodium is in group 1, so we will draw 1 outer electron. Chlorine is in group 7, so we will draw 7 outer electrons. These are called dot and cross diagrams. We show the electrons on one atom with a dot and on the other with a cross. This is so we can tell the electrons apart. We know which electrons are sodium's electrons and which electrons are chlorine's electrons. We'll then draw an after picture and figure out what's happened to the electrons. Sodium's got 1 outer electron and it wants to lose that electron. Chlorine has got 7 outer electrons and it wants to gain 1 electron. So sodium's outer electron is going to be lost and transferred to the chlorine. Therefore, chlorine now has a full shell of 8, and we can see the electron has travelled from the sodium to the chlorine. Sodium now has an empty shell, but there will be a full shell underneath that. We just don't show that on the diagram. We now put the ions in square brackets and write their charge. Sodium has lost 1 electron, so it's going to be positive. And chlorine has gained 1 electron, so it's going to be negative. So far we've answered the first part of the question. We've drawn the bonding in sodium chloride. We now need to write sentences explaining what has happened to each of the ions to do the explain part. So sodium has lost 1 electron and become Na+. And chlorine has gained 1 electron and become Cl-. An ionic bond is the electrostatic force of attraction between oppositely charged ions. It's always a good idea to add the definition of ionic bonding to the end of a question like this to make sure you get all of the marks available. For this question, we're going to draw and explain the bonding in magnesium chloride, following exactly the same steps we've just been through. So we'll start off by drawing a before picture of both of the atoms. Magnesium is in group 2, so it will have 2 outer electrons, and oxygen is in group 6, so it will have 6 outer electrons. We'll then draw the after picture. So magnesium is going to lose both of its electrons, and they're going to go to oxygen, because magnesium needs to lose 2, oxygen needs to gain 2, so it works for the magnesium electrons to move over to the oxygen. We'll draw our after picture to show that, making sure our electrons are dots and crosses, so we can see that these 2 electrons here must have originally come from the magnesium. And we'll then draw our charges on. So oxygen has gained 2 electrons, so it's gained 2 negative charges, so its charge will be 2-. Magnesium has lost 2 electrons, so lost 2 negative charges, so its charge will be 2+. We'll then need to write sentences describing what's happened to the magnesium and the oxygen and our definition of ionic bonding. So magnesium has lost 2 electrons and become Mg2+. Oxygen has gained 2 electrons and become O2-. Make sure to include the specific charge rather than just saying become positive or negative. And we'll then include our definition of ionic bonding, which is that an ionic bond is the electrostatic force of attraction between oppositely charged ions. In this example, we need to draw and explain the bonding in magnesium chloride. So we'll draw our before picture and add the electrons in. However, in this case, chlorine only needs to gain 1 electron, so if we moved 1 electron from the magnesium to the chlorine, it would mean that the magnesium would still have 1 electron left over. If the magnesium has 1 electron left over, then it has still got an electron in its outer shell, and we know magnesium needs to lose both of them, so this can't be correct. The solution to this problem is to have a second chlorine atom. If we have 2 chlorines, each chlorine needs to gain 1, magnesium needs to lose 2, so magnesium can lose 2 electrons, and 1 electron can go to each chlorine. We represent this on the diagram by drawing a big number 2 in front of the chlorine in both the before picture and the after picture. This means we've got 2 chlorines before, forming 2 chlorines afterwards. And we'll then add the charges to each ion. So magnesium has lost 2 electrons, lost 2 negative charges, so it'll be Mg2+. 2 chlorines have each gained 1, so their charge is still just 1 negative, because if we compare the chlorine before to the chlorine afterwards, each chlorine has only gained 1, so each will only have a 1 negative charge. As before, we'll need to write the sentences for each. So magnesium has lost 2 electrons and become Mg2+. Two chlorines have each gained 1 electron and become 2 lots of Cl-. And an ionic bond is the electrostatic force of attraction between oppositely charged ions. We'll now draw and explain the bonding in sodium oxide. We'll draw the before pictures showing the outer electrons, and what we'll notice this time is that sodium needs to lose 1, but oxygen needs to gain 2. So in order for oxygen to gain 2 electrons, we must need to have 2 sodiums, which we'll represent by drawing a big number 2. We'll then draw an after picture, making sure the big number 2 gets copied across. And we'll add in our outer electrons and our charges. So 2 sodiums have each lost 1 electron. So therefore, the sodiums will have a positive charge because they've each just lost 1. Oxygen has gained 2 electrons, so it will have a 2 negative charge. We'll then write the sentences to explain what has happened. So 2 sodiums have each lost 1 electron and become 2 lots of Na+. Oxygen has gained 2 electrons and become O2-. And an ionic bond is the electrostatic force of attraction between oppositely charged ions.